Hi, welcome to another video. So today we're going to look at a series of compounds and we're going to rank them in order of their acidity. So these are the compounds. So these are the four compounds that we're going to look at, and we're going to look at the acidity of these compounds. So the acidity has got to do with how much the O- is stabilized. Okay, so looking at the groups that are attached, so we've got a benzene ring with two chlorines. So remember, these chlorines are delta negative. Okay, so they're going to be pulling electrons from that benzene ring onto themselves. And in doing so, it's going to be tying the O- more into that benzene ring because it's kind of like that pull into the ring. If we look at these CH3s, they're actually delta positive carbons. So they're not going to be pulling, they're going to be pushing electrons, leaving them in the ring. So that's going to be tying this O- up less in that ring and making it more stable sitting out there. If we look here, we've just got a normal benzene attached to the O-, so it's going to be stabilized through the resonance structures that can be formed for this particular compound. So they'll be tied into this system. The same with this one here, and there's no destabilizing or anything occurring. There's no more stabilizing occurring. It's just a plain benzene ring. And this one is just an O- that's not stabilized by the delocalized electrons. So this is just a hexane ring. So in terms of the two extremes, this one would be the least acidic. So we've got 4, so let's number this number 4, the least acidic. Now, in terms of the stabilization of that O-, the CH3s being electronegative, that would be the most acidic O-. Now, between these two, we've got just the O- on the benzene ring, and then we've got the one with the methyl. So this one actually comes in second position, and this one would come in at that third position. Okay. So this will be the most acidic, the second most acidic, the third most acidic, and the fourth or the least acidic. So this doesn't have many resonance structures, so it's the least acidic. So take home, electronegative groups attached to the benzene ring will increase the acidity of that O- that's attached. The benzene ring in itself helps stabilize that O-. If you have delta positive groups, it will destabilize it to a degree compared to just if there were no groups attached. And if there's no delocalized system of electrons, then you're going to have a very unstable hexane ring. So thank you very much for watching this video, and I hope this gave you some insight into the acidity of compounds.